Okay, so hello everyone, and thank you for watching my session about Dapper runtime. I am Christophe Gigax, a cloud solution architect at Hardy Group and also MVP Microsoft. Before going deep into a Dapper runtime, let me just remind us what is a microservices architecture. Why do we often choose a microservices architecture? First, we want our microservices to be focused on a specific business aspect of our solution. This allows us to gain more autonomy, flexibility, and scalability. And it allows also the teams to be more flexible, independent into the development and the deployment. In summary, what we want smaller services, but more efficient. Of course, this comes also with some difficulties. So, for example, the debugging process and the testability. For example, you want to debug a feature or fix a bug that implies a lot of services of your architecture. You have to run all your services in your local environment. This increases the complexity of your, and you also have some difficulties with the interdependencies of your service. At the end, you just doesn't understand what is going on in your solution. And also you don't master and you can manage properly the flows inside your application. To summarize this, it's difficult to migrate from a monolithic block to a microservices architecture. And today, the languages and the framework that you use are not natively oriented for microservices. At the end, about hosting model, it's not so much true today, but application tied to a specific infrastructure or platform with limited portability to cloud or edge. And that's why Dapr comes to the landscape. Dapr is the acronym for Distributed Application Runtime, and it's a portable, event-driven runtime for building distributed application, and you can run it in the cloud or in the edge. Dapr comes with very specific objectives for you and for developer teams. It comes with best practices and some building blocks. So, for example, if you install Dapper on your local machines, it will, on the shelf, comes with some blocks that you can already use for your applications. We will go through it just a little bit later. You can use any language or framework that you want with Dapper, and it's community driven. It's a non commercial initiative and it's into the CNCF ecosystem today. It will allow us to adopt some standards into our architecture. I will come to it just later also. And it's built on a consistent, portable, and open APIs. That means that you can very easily interact with the runtime if you want to. It's platform agnostic from cloud to edge. That's because it's built on containers technology. And it's really extensible with pluggable components. Today, there are more than 100 components that you can use on the shell with Dapper, but of course, you can create your own components with the extensible aspect of Dapper. About the basis of Dapper, first, you have to understand that Dapper implements the sidecar pattern. That means that when you launch your service, automatically a Dapper sidecar will come in live just aside of your service. And with this sidecar pattern, that means that every interaction that you do outside of your service will be handled by Dapper. That means that your code only knows about Dapper as an external dependencies, and that's only that your code will know. For example, when you want to invoke another service or you want to store some data in a database, you will go through Dapper to perform this action, and your code will be agnostic from the technical implementation of the component at the end. For example, we have here two examples. You can interact with Dapper through HTTP or gRPC. And the first example will tell Dapper to store some data into the state that you mentioned into the URL. So you tell Dapper to store the data, and Dapper will take care of the implementation details of the database at the end. It depends. In fact, it's everything about configuration into Dapper, about the component you have at the end. The second example is service to service invocation. So here, the example, it said that I want to invoke the service my app and the method new order in that service. That means that Dapper will automatically perform a service discovery process, and it will automatically also call that method in the right declared service into Dapper. Like I said, you can use any languages or framework you want with Dapper because it's built on container technology. And then you will call some HTTP API or gRPC API to perform some external interaction that your code needs to perform for your business logic. So you can do service-to-service invocation, state management, pub sub, resource binding and triggers, and actors pattern if you want to, distributed tracing, and secrets, and so on. So what you need to keep in mind is that Dapper is a sidecar pattern. And when you want to perform some external operation, you will go through Dapper to perform that action. So your code will only focus on the business aspects of your solutions, and everything else will be handled by Dapper, all the external interaction. So here is an example of the sidecar model I just mentioned. So when you have one service, one sidecar will appear just aside of your application, and then you will call some API to perform some action on Dapper. So you can invoke another method in another application. You can store or retrieve some state stored in a database that you configure into Dapper. You can publish a message, so you can publish and receive messages with Dapper, and you can retrieve some secrets that are stored and handled by Dapper. For example, here is a local example of a very simple architecture with Dapper. So I have a service A and a service B, and each of those services has a sidecar, a Dapper sidecar, just aside of the service. And then after that, I will configure Dapper about the state store I want to use or the event broker I want to use, and so on. For example, for the state store, you could use DynamoDB or CosmosDB or Redis. For the pub sub, you could use a RabbitMQ, Service Bus, what you want. So the implementation details is only into the Dapper configuration, but your service doesn't know about this detail. It only knows about how to interact with Dapper. And I can just show an example of that. So we'll just switch to my VS Code editor. And then here I opened one of the GitHub repository of Dapper, which is the quick start repository. And inside of it, you have a lot of examples that you can reproduce for your solution. Here, what I will show you is a very simple example so that you can understand how it works. For example, here I have a Node.js application. That Node.js application exposes a very simple API to get an order and to create here a new order. For the application to get the data, it will store a new order and get a new order from a particular database. But here, the application doesn't know about the database. It only knows about Dapper. So here is the URL we will use to store and retrieve the data. We are working locally, so we will use localhost. The Dapper port is by default 3000, and 3000, is for the Node.js application port. It will use 3500 ports for the port for Dapper, in fact. And then I will use here the state URL, and I give to Dapper a name of the state that was configured for Dapper so that he will know that this particular database is tied to a particular name. And that's what I will use in my code to store the data. In order to launch the application with Dapper, I will use the Dapper CLI. So first you have to install the Dapper CLI in your local machine. Everything is explained on the documentation. I will not deep dive into it because it's really simple and everything is explained on the website. And then you have to launch the Dapper init command line in order to install everything you need on your local machine for Dapper. So I've already done it in the past. So then when everything is set up, you can use the Dapper run command with the app ID option. This tells Dapper what is the ID of this particular service into your microservices ecosystem. And this ID should be unique per service, of course. So here I will use the option with the node app value. The app port is, like I said, 3000. And I will just, to be sure, I will use this option to tell which port Dapper will use. So Dapper HTTP port. And at the end, I will just tell Dapper which command he needs to use in order to launch my Node.js application. So to launch a Node.js application, I will just use node app.js. So this is the command I need to use. I'm just not in the right folder. So let me just jump into the right folder. Hello world and node. So I will just copy paste the command line. So Dapper run, app ID, apper, and node app.js. When you launch that command, you have a lot of logs. In fact, I will not go into everything, but just to show you what Dapper tells when you launch the runtime. So first you have in blue the logs of your application. So for example, here I can see that my applications is correctly running on this port. And then about the Dapper logs, you can see that it's loading a lot of components. So the state store component. Here we have a Redis component, which will be used by the example to store my orders. What you need to know actually is when you launch Dapper the first time, it will, when you launch and install Dapper the first time, it will install some container images on your local machine. And it will, in fact, install a Redis container in your machine. And when you launch the Dapper or runtime, it will automatically launch a new container, a new Redis container. And that's what is configured by default when you launch Dapper. And by default, this will use the Redis state store. So here is the component for the state store. And by default, there is also another configuration into Dapper for a pub sub component. And this is also Redis. So if I check the log, I can see that everything works correctly. Application discovered on this port, node app. Everything sounds okay. Dapper initialized, status running. Okay. So apparently everything is good. I will just show you something else. Yeah. I will create a new terminal here. And what does that sample do is, so we have one microservices in Node.js and we have another one in Python here. This Python is only a simple client for the Node application, and it will only create new order in a loop indefinitely. And this will use Dapper as a sidecar for the Python application in order to call the Node.js application. So the Python application doesn't know or doesn't call directly the Node.js application. It will only call Dapper, and Dapper will forward the request to the right service. I will launch that application too. So tutorial hello world Python. And also for Python, I will also use the Dapper run app ID Python app. And then I will just tell Dapper which command he should use to launch the application. So Python app.py. Like I said, this is just an infinite loop that calls the API in Node.js. And then I can see that in my log from the Node.js application, the Python application correctly reached the Node.js application to create new order in a loop. So that's really easy. So as you can see, my code is really clean in terms of external dependencies. I only use Dapper with standard API. So here it's HTTP. And when I want to perform some external action, service to service invocation, state store for the Node.js application, I only use Dapper and I don't know implementation detail of my infrastructure dependencies. Okay, so I will just stop this, and then we can go again to the slide. This is just a recap of the demo I just showed. So we have a front-end application and a back-end application. Both has their own sidecar Dapper. And when I want to invoke one service from the first microservice, so for example, the front end, I call Dapper through a standard API, and then Dapper will automatically forward the request to the right microservice behind. That's how the service invocation works. Of course, at the end, the ultimate goal is to deploy in production Dapper, and then the recommended way is to use Kubernetes. So when you initialize Dapper on Kubernetes, it will install 4 system pods into Kubernetes. So I won't go in deep details into each pod because it's well explained to the documentation and it's not the goal of this session. But you have the actor placement pod, the sidecar injector pod, the sentry. This is for security, and operator. For example, the sidecar injector will handle all the injection of the sidecar pattern into each pod of your microservices architecture. So each container that is deployed into Kubernetes, it will be added to a pod, and that pod will have a new sidecar instantiated into the pod with your container. And then when you have this setup, you just have to configure Dapper like you will do in the local mode. You configure Dapper to tell which infrastructure component you want to use for the resource binding, state store, and so on. And you code into your microservice. We only talk to Dapper into your cluster in order to perform some external operation. And then with that architecture, you can deploy Dapper and your service everywhere you want. It could be Azure, AWS, or on the edge, on-prem, as you want. So about Dapper components. So we have plenty of components for each category that Dapper supports. The configuration is done through YAML files, and you will put here every details, in fact, every implementation details that Dapper needs to get to connect to those components. So you have a dedicated YAML file for state store, for pub subbroker, binding, secret store, and so on. And for example, for state store, if you choose AWS DynamoDB, you have one YAML file that will handle or will get all the connection details to in order for Dapper to connect to that DB. And it's the exact same principle for everything about Dapper components. Here is an example of pub sub pattern with Dapper. So here I have 3 microservices that needs to exchange messages between those microservices. So first, on the left, your application will post a new message or publish a new message here to Dapper. Dapper will forward the message to the correct broker that is configured with a YAML file. So here it's a Redis cache. And then all the service that listen to that particular topic will get the message. How it works is in that way, your service A, B will expose an API that Dapper will call when it receive a new message. That's how it works. So it will push a message into a particular API declared in Dapper. For the telemetry, it's mostly the same principle. So Dapper implements the Open Telemetry standard. So all the tools that implement that standard, AppInsight, Datadog, Prometheus, and so on, you can use any component you want, link it to Dapper, and you can just in your application log what you want in your code, and Dapper will gather the log and send it automatically to your tool. So it's and then with that principle, you can change the tool whenever you want because you have that standard open telemetry in the middle. Just to finish this session, just a reminder about the projects in the CNCF context. Dapper was accepted as a graduated CNCF project in November 2024. And as you can see, the community is very big, and a lot of big companies already added this technology in their stacks and already using it in production. So it's a very big project today and very solid and reliable in terms of cloud deployment today. If you have any question or feedbacks, don't hesitate to reach me on Blue Sky or on LinkedIn. I'm very open to question about Dapper, and I really encourage you to check the GitHub repository and the community around Dapper. And why not make some contribution or use it in production for your microservices architecture. Thank you for watching and have a nice day. Thank you.